in this lesson, we're going to talk about transformations, and we're going to talk about what is parent function and how to transform those parent functions by adding something to the function both inside and outside. Let's begin by talking about what is a parent function. So a parent function is the simplest form of a family of functions. We have three here. We're actually only going to use the first two in this course, but I thought I'd show you the third one just so that you would have that for reference. So the first one is linear. That's the red graph that we have here, and that is f of x equals just plain x. If you think of the f of x as y, this is just y equals x. 1, 1, 2, 2, 3, 3, 4, 4 are all graphed because y is equal to x. It's the simplest function of a family of functions. But all linear graphs have this red line as a shape. They're just transformed. Maybe it's steeper, maybe it's not as steep, maybe it's translated up or down or left or right, but it's always going to have that shape. The second graph we have, the big V, is the absolute value function. That's f of x equals the absolute value of x. Again, I can shift that up or down. I can horizontally stretch it. I can vertically shrink it. I can change the steepness of it, but all absolute value functions have that V shape. And then we have the quadratic. Any function that has a 2 as the highest exponent in the function is going to have this shape of this U, which we call a parabola. And again, I can make the parabola wider or shift it up or down, but if it has an exponent of 2, it's going to have that shape for the graph. I just thought this was a fun image. These are some more parent functions shown by your arms. Normally, if you're in my class, we would do a little dance moves with our arms demonstrating the different parent functions, but here are our linear functions, and our absolute value functions is a big V, and then the x squared looks like a touchdown. This is a circle graph, but there's lots of different parent functions. We just only deal with absolute value and linear in Algebra 1. So the significance of a parent function is that it can be transformed or changed by adding or subtracting values to the function or its input values. So we can add them to the whole function itself or to its input values, and then we can transform it. It's still going to have that same shape, either the straight line or the V or the U, but it's going to be stretched or moved in some way. So let's look at how that happens. When f of x is transformed by f of x plus d, the linear function shifts or is translated vertically. So when it's added to the entire function on the what I call the outside of the function, I'll show you what that means in a minute, it's going to shift the entire parent function graph, whatever it is, the line, the big V, the U, it's going to shift it up d units or down d units. If it's a plus d on the outside, it goes up, and if it's a minus d, it goes down. So let's look at some examples and why that happens. Here's the first example. Describe how the function given relates to the parent function f of x equals x. Then graph and label the function on the graph with the parent function. Whew, that's a lot. Are you tired yet? It's not bad. Let's just talk about what it means. All right, so that first sentence says, describe how the function given relates to the parent function f of x equals x. So they're telling you this has the parent function of f of x equals x. It's linear. Then graph and label the function on the graph with the parent function. So here we have a new function, g of x. That's why it's got a different name. And it says we're going to take the original function, which is the one that's graphed here, and we're going to add 6 to it. So according to our previous slide, if it's a plus d, it's going to shift the line up d units. So this should shift the line up 6 units. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we could keep doing that if we wanted to, but I have better things to do with my life, so I'm just going to use the straight edge tool and connect those dots. Okay. Now, notice the slope is the same, but the y-intercept has changed. It has changed from 0 to 6. But the slope is still the same. That has not changed with this transformation. Real quick, I want to show you what this looks like in table form so you understand why it's happening maybe. I'm going to do my x's are 0, 1, 2, 3. My f of x, this is my output. What is my output for f of x equals x? If the input is 0, then the output is 0. If the input is 1, the output is 1. The input is 2, the output is 3. The input is 3. Oh, I messed that up, didn't I? I started singing and I ruined it all. Okay, so that's what I have plotted here. 0, 0, 1, 1, 2, 2, 3, 3. You see? Now, what I'm going to do is I'm going to add 6 to the output. So instead of being 0, 0, it's going to be 0, 6. Instead of being 1, 1, it's going to be 1, 7, because I'm going to add 6 to my, I'm going to add 6 to my outputs here. Add 6 to this would be 8. Add 6 to this would be 9. So 0, 6, 1, 7, 2, 8, 3, 9. 0, 6, 2, 7, 3, 8. You can't see 2, 8, 3, 9. You can't see that on the graph. But we're adding 6 to the outputs, and that's why it moves it up, because that's a change in the y value if you're talking about outputs. Now we're going to do the parent function as f of x equals the absolute value of x. Then graph and label the function on the graph with the parent function. So this one says g of x, that's going to be our new graph, is f of x minus 1. So we know from before, if you didn't write this down, you should, that f of x minus d on the if we're taking the outputs and we're subtracting d, it's going to shift the line down d units. So if I go back to here, I'm going to go down 1. And that's going to be my new graph. But it's always good to analyze these things with a table too. So we're going to stick with that same 0, 1, but I'm going to also do -1 and -2 because it's absolute value, so that does some kind of fun things. So for an f of x for absolute value of x, we're going to turn all of these positive if they're not already positive. And that's why we end up with this v. Because all my negative values are going to have the same y values as their positive partners. Because 1 is 1, but then also -1 is 1. It's still a function. It's still a function because 1 is paired with 1 and not other things. -1 is also paired just with 1. So it's still a function, but that's why we end up with this v. Instead of going down like this, it makes a turn at 0 and starts going positive because it's absolute value. Now let's take a look at what happens when you subtract 1 from these outputs. So instead of 0, it's going to be -1. Instead of 1, it's going to be 0. Instead of 1, it's going to be 0. I repeated myself on purpose that time. 2 minus 1 is 1. So you can see that all of my outputs shifted down 1, and that's why the graph went down 1. All right, one more example with plus d transformations. So two students transformed f of x equals x as shown below. So here is the original parent function of f of x equals x. Use the graph to answer the questions. First question. Luis graphed g of x equals f of x minus 4. Which is Luis's line? Let me label them. Is his A or B? If you said B, you are correct. This is going to move the f of x down 4. 1, 2, 3, 4. There it is. Cora, second question, Cora graphed the second line. Which is Cora's line? Well, it has to be A, right? Cora's line is h of x. So what would hers be? Well, it would be f of x, and then what did we do to the original parent function to get line A? It moved 1, 2, 3, 4, up 4. So her line would be h of x equals f of x plus 4. We take the original function and we add 4 because it moved up 4. Whereas Luis's line took the original function and it moved it down 4, subtract 4. Third question, how did the slopes and the y-intercepts of the student's line compare to the parent function? The slopes are the same. same steepness. The y-intercepts are not same. They are the same as the y-intercept of Luis's is -4, and the y-intercept of Cora's is +4. Now let's talk about when f of x is transformed with minus c on the inputs. So when f of x is transformed by f of x minus c inside the parentheses here, notice how it's inside the parentheses, the linear function shifts or is translated horizontally. So by horizontally, we mean it's going to go left or right. So f of x plus c will shift the line left, and f of x minus c will shift the line right. And that may be surprising to you, but it's what happens. So when it's a plus c, it's going to go left, and when it's a minus c, it's going to go right. And notice here, we're adding and subtracting to the input instead of the output now. All right, so let's take a look at some examples. Again, describe how the function below relates to the parent function and then graph the given function. So this is our parent function, f of x equals x. And our new function, m of x, is going to take it and move it to the right. You'd think minus would be to the left, but it's actually going to move it to the right. So it's going to look like this. I'm just shifting them right this way. Okay, so to look at what this looks like might be a little bit confusing, but if it's x and then f of x, those are all equal. Then for what we're doing here is when we put x of 0, then we're actually looking at 0 minus 1, which is -1, and f of -1 is -1. If we put in 1, then this would be f of 1 minus 1, which means we're finding f of 0, which is 0. If we put in 2, then we're really finding f of 1, which is 1. And if we put in 3, then we're really finding 2, which is 2. And that's why it shifts the graph 1, 0, 2, 1, 3, 2, 4, 3, and so on. If the table was confusing, don't worry about it. It's going to be fine. Just remember that if it's on the inside of the parentheses, it's going to be a move left or right, and it's going to go the opposite of what you think. So it's +2 here, so normally that would mean go in the positive direction, but we're actually going to move in the negative direction. So we're going to move each point to the left 2. That's going to take that whole v, is still going to have that absolute value shape of the original parent function, and it's going to move it to the left 2. Just like that. One more example, the parent function was shifted horizontally. So that's key, that it's telling you that it's a horizontal shift to create function g. So f was moved horizontally, which means left and right, to create g. Write a function to represent g. So g of x equals f of x. It's going to be on the inside because it's a horizontal shift. So I'm going to put the plus or the minus inside the parentheses. And it's moved 3 to the left. So that's going to be a +3, the opposite of what you think it should be. Up and down, exactly what you think it should be. +3 is +3. Moving up 3 is +3. If you move it to the left 3, instead of it being -3, it's going to be +3. Hopefully now you have some idea about how to transform functions left and right, and also up and down.